So day 2 of 18.1 is comparing functions. Really is the only new thing that comes about. You know, it repeats graphing, finding the vertex, axes of symmetry, minimum over maximum. It talks more about what makes the function open up, what makes a function open down. How can you tell that from an equation? But I pretty much talked about that on 18.1, day 1 as I went through. And evaluating at a certain value, I think we did that a little bit, but it hits more on that. So those are the things you need to be able to do. Now the textbook has some extra things, so be aware that you don't need all of section 18.1 for this class, so you might just want to take a look at that, watch the video, make sure you don't overload your brain. It's great if you learn more, but you don't need to. This is what you need. You always also know what you need by doing the homework and the skills practice. We've picked those problems out specifically. So the basic parabola either faces up or down, and these two parabolas are y equals, in the form of y equals ax squared, where a is a number. Okay, so this one faces up because a is greater than 1. This one, or greater than, sorry, positive number, greater than 0. And this one faces down, and it's y equals negative a x squared, meaning that there's a negative coefficient in front of that x squared, and that a is less than 0. So these are the two parabolas that you'll be dealing with. Like I said before, sideways, they don't ever go this way or this way, then they aren't a function. So let me reverse that. So some of the problems will ask you, you know, does y equals 4x squared, and they'll have a bunch of pictures, and they'll say, you know, which one is it? Is it this one or this one? And you can just cross that out, and that way, if there's other options, you can narrow it down. Okay. The other thing that this section covers is what happens to graphs, to functions, when you have the leading coefficient be greater than 1 and less than 1. So this example comes right out of the textbook. You can look it up if you want. So here's this one right here is what y equals x squared looks like. Okay, so ignore the little y2. That just means the second picture. So they consider the blue one the first picture, the pink one the second picture, and the green one the third. So that's why the y's have these little numbers next to them, these sub numbers. But this one is the main one. Okay, so that's y equals x squared. So that would be like 1 x squared. When you have a number less than 1, how do you describe what happens to your parabola? So if you have fractions or decimals out there as a leading coefficient, what's happening to that parabola? It's getting wider. Okay, the reason it's getting wider is, think about, this is the x, right? And if I have a, if you think about tables, if I have y equals x squared, and I make an x and a y table, and I have y equals 1/2 x squared, and I make that same x and y table. Let's take a look at what happens when you graph this function. So if you have x equals 0, of course you're going to have y equals 0. And on this one, you're going to have the same thing. So right now they're the same, and that's their vertex. Okay, so then if I put a 1 in here, 1 squared is 1. So to graph this point, I went to the right 1 and up 1. If I put a 1 in here, I get a half as a y. So that means to graph this one, I go over 1 and only up a little bit, half of what I was going up. Okay, so if I put a 2 in here, I get 4. So I go over 2, up 4. But if I put a 2 in here, I only get 2. So I go over 2, but then I just go up 2. So it gets wider. When you put when your a is greater than 1, like in this one where it's y equals 2x squared, then it gets narrower than the basic parabola. Because if you make that y equals 2x squared, that same idea, if I go to graph this, 0, 0, of course the green started where all the others do at the vertex, and if I put a 1 in here, I get 2, so I went over 1 and up 2, so I'm going up faster than I'm going over, which is making it narrower. You will in the homework be asked, what will happen to this equation, what will happen to this, what will this graph look like, what will this graph look like compared to this. So most of the time they'll compare to your basic function for right now. So they'll say compared to y equals x squared, what would y equals 1/3 x squared look like? And you would say wider. Okay. The same thing happens when it's upside down. The only difference is that all these a's, or these leading coefficients, are negative. And we just talked about that. So let's see how much you understand on that. And I think they use f of x instead of y. So if I said f of x equals x squared, and I said compare that graph to f of x equals 5x squared, what would you say? You would need to say that this one gets narrower and it opens up. If I said f of x equals 1/3 x squared, and I asked you again to compare it back to the original, then you would say it gets wider and it opens up. If I said f of x equals -1/5 x squared, and I asked you then to compare it to this one. Well, this fraction is smaller than 1/3 and it's negative, so it even gets wider yet and it opens down. But I believe on all the homework they keep asking you to compare back to the original. But you should be able to bounce off of other ones too. Just to make sure you remember what you learned in the last section. If I don't remember how they use these figures in the book, but if I asked you to tell me the vertex of this first figure, you should be able to give me the ordered pair 1, -3, because the vertex is right there. If I asked you for the axes of symmetry, then you know that it's this line that cuts it in half. That line runs through the x-axis of 1, so it's x equals 1. And then if I asked you if it was a maximum or a minimum, you should be able to tell me that this is a minimum because the smallest point is down here. And that minimum, if I asked you for the y, I wouldn't ask you for the x because x won't tell you how low it's coming. The y-axis is the one that runs up and down. And so if I asked you for the y coordinate at that point, you'd say y equals 1. Okay, same thing on this one. If I asked you for the vertex, you might pause it and see if you can do it yourself. If I asked you for the vertex, you should say 2, 4, the point 2, 4. If I asked you for the axes of symmetry, you would say x equals 2. And if I asked you if it had a minimum or a maximum, you would tell me a maximum of 4. Whoops, and I screwed up on this last one. I just realized that. That should be a minimum of -3. Sorry about that. Okay, so the next part is, can you graph them and then do all those things like the vertex, the axes of symmetry, find a minimum or a maximum, and also evaluate a certain point on the graph. So we'll go through that. So we're going to graph this. Now remember, to graph it, you might as well find the vertex first and then make a table of things. So the vertex was x equals -b over 2a. So you can see that there is no b because there's x squared and there's no x, and then there's 3. So the a, if you remember from yesterday or whenever you studied 18.1, the a is 1 because the a is always the leading or the coefficient in front of the x squared. B is 0. C is -3. And you don't need C right now. So I'm going to have 0 over, who cares? It's just going to equal 0, because 0 over anything is 0. So I know the x value is 0. I'm going to make a chart. I'm going to put it here because I want to put some points around it. So if I plug 0 in, I get, remember that the function is x squared minus 3. So if I plug 0 in, I get 0 squared minus 3, which is just -3. So I know the vertex is -3. 0, -3. So 0, 1, 2, 3. So I'm going to put a point there. This is going to be fun. This is going to be interesting, me graphing on this. This pen is so fat. So we'll give it a shot. Also, can you answer the question, is it going to face up or down? So you should know it's going to face up because the coefficient in front of x squared is a positive. So I want to know what's going on over here and over here. Like, how does this face up? Is it like this? Is it like this? Is it like this? And so I want to pick some x's that are over here and plug them in. So I'm going to pick x2, and I just picked it out of random. Okay, you can pick 1 if you want to. I'm just going to pick 2. So I'm going to see what happens if I do 2. And you don't have to do these in order like I am. So that would be 2 squared minus 3. So 4 minus 3 is 1. So I should have erased that first. Sorry. Hold on. So over 2 and up 1. So I know that the axis of symmetry is right here. So I know for sure if there's one on that, two squares away on this side, that there's 2 squares away on that side. So I'm going to go ahead, oops, I'm going to go ahead and put it in there. Okay, and you don't want to graph a parabola just with 3 points. You want to know, is it wider, is it skinnier? So I already know it's coming up like this, at least. So I'm going to go ahead and put 1, 2, 3. I'm going to put x equals 3. So if x equals 3, it's going to get big real fast because 3 squared minus 3. 3 squared is 9. 9 minus 3 is 6. So 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, and then again, I know that that's 3 jumps away from the axis of symmetry, so it's going to be 3 jumps that way. And that gives me a better idea of graphing the parabola. Parabolas go on forever in both directions, so you want to make sure you put arrows on them. And that they aren't a V, they're rounded at the end. So one of the things you're going to have to do is graph. The other thing is name all those things. So what is the vertex? Well, the vertex is this point down here at the bottom. So it's 0, -3. It has a minimum. Let's see, what else do they... Oh, there's my dog. Axis of symmetry is x equals 0. And then also what they ask you in this section is they'll go... let me give myself some room here. they'll say evaluate f of, -2 or whatever. So all that means is that you're just finding when x is -2. So it's just what we've been doing. They're just going to give you a specific one to evaluate. So remember, if you're using your calculator, all negatives, put parentheses around them if you're going to use the exponent button. -2 times -2 is 4. 4 minus 3 is 1, and we already knew that. That was a point we already had. So then you'd say 1. So that's the only extra part that they're going to ask you. Let's try another one. How about f of x equals -x squared minus 2x plus 5. Whoops. So let's see, these are the things I'm going to ask you to do, is graph it. I'll tell you all the things so you can pause it if you want to. Identify the vertex. Identify the axes of symmetry. State whether it's a minimum or maximum. And let's see. Evaluate, I don't know, I'm just going to make it up, but f of 2. I don't remember what the textbook used. So all of those things. And then right now, while you're thinking about it, do you think this faces up or down? You should know it faces down because that's a negative. So if yours doesn't face down, then you know you screwed up. And what that's nice for too is that, like I said before, sometimes they'll make you graph it yourself. Sometimes they'll have 4 different graphs there, and they'll say which one of these is the matches the equation. The easiest way to do those is to cross off the ones that you know are facing the wrong way, and then find the vertex with your vertex formula, and that way you don't have to sit there and graph it on a piece of paper. You can do process of elimination, and you can get through the problems faster. And it's all about knowing how to do that anyway. So you can pause it and try those if you want, and then when you come back to play, I will show you how to do it. Okay, so I'm going to make an x and a y value. I'm going to first find my vertex, which I know is x equals -b over 2a. So x equals -2 over 2 times -1. And that's going to be a +2 over -2, which is a -1. So I'm going to go ahead and erase all this. So my vertex, my x is -1. I got to find my y. So I'm going to plug it in. So I have -1. Again, if you're using your calculator, which I encourage you to use your calculator on these, so that you don't make simple errors. Whoops, plus 5. Bristol, go away. There's the dog. Plus 5. Again, if you're using your calculator, type it in exactly like that. Make sure you use those parentheses. So that's going to equal 6. So I have -1 and 6. Back 1 and up 6. And I'm going to erase this. And there's my vertex. And I'm going to plug a 0 in, just because it'll be easy. And 0 is going to be 5, so 0, 1, 2, 3, 4, 5. So I know there's another one on the other side. I can go ahead and do my axes of symmetry. That's going to equal -1. And I need some more values to be able to know how wide this is. And the reason why too is later on we talk about where it crosses the x-axis. It becomes important in story problems. So I'm going to go ahead and put 3 in there. So that would be negative 3 squared minus 2 times 3 plus 5. So negative 9 minus 6 plus 5. And that's going to be negative 15 plus 5 is negative 10. 1, 2, 3, 1, 2, 3, 4, 5, 6, and I don't even have enough room. And if I put 1 in there, I get 2. So over 1 up 2. It gives me an idea of how it goes. And maybe I'll put 2 in there. If I put 2 in there, I get negative 3. So 1, 2, 1, 2, 3. And there we go. Okay, so I know that I have a maximum. And I evaluated f of 2, and I got negative 3. The only other thing that might be tricky is they had you graphing problems that were not in the quadratic form, and we kind of talked about that in 18.1. If it's not in the ax plus by equals c form, if it's not in that form, then you need to make it, you don't have to, but it's a good idea to make it into that form before you start. So on this one, I would probably multiply that out. You can use your shortcuts if you remember shortcuts. If not, go ahead and FOIL. That's one of those special ones that had a shortcut. Sometimes when you're first starting out, those shortcuts are not a good idea because you start memorizing them for a little bit, but you don't really understand why the shortcut is that way, and then it's not good. So x squared plus 4x plus 4. Plus, when it's in this form, you can start answering those questions like, does it open up, does it open down, how do you find the vertex? You can't really find the vertex. Well, you can, but you're going to want to find the vertex from this form that we showed you so far. So that's the second part of 18.1.